Thank you very much for joining us for this webinar on passive sampling. This year, Professor Stedler published an article on the review Environmental Advances. They have shown the applicability of using passive sampler to monitor metals and organic pollutants during a phytoremediation period to measure the effectiveness in contaminant removal. We therefore have asked Professor David Stedler from the University of Lausanne to participate in this webinar. We are delighted that Professor Stedler has accepted our invitation to share some results and discuss them with you. Professor Stedler, a short presentation of Professor Stedler first. Professor Stedler obtained a PhD at École Polytechnique Fédérale de Lausanne and has pursued a career in both academia and the private sector. He is a CEO, administrator, or founder of several companies, including Tibio, Fratale Gruppe, or Daxtachem, companies in the field of biotechnology and environment. At the same time, he is also titular professor in analytical chemistry at the Department of Biomedical Sciences of the University of Lausanne in Switzerland. The webinar is entitled From Detection to Remediation, the Role of Passive Sampling in Monitoring Brackish Waters. Professor Stedler and his partners carried out an assessment of seasonal and temporal variation of pesticides and metals in the brackish waters of the Camargue. This is a very difficult environment influenced by rainfalls, evaporation period, agricultural practices, and variation of the salinity level. To do so, they have used AttractSP POCIS HLB containing PRC and DGT devices exposed during 21 days on 8 sites for a period of 11 months. During the webinar, feel free to ask your question in the chat room. It will answer to your question after the webinar. In addition, you should be able to read online subtitle of the presentation by activating the option subtitle on the lower part of the screen. Our sincere thanks to Professor Stedler for his participation to this webinar. First, my colleague Louna will shortly introduce you the Affinisep products related to passive sampling, and then we will follow with the presentation of Professor Stedler. Thanks a lot for attending.
Hi, thank you all for joining for our webinar. I'm Louna, working for Affinisep as a sales engineer, and I'm going to briefly introduce you Affinisep. So first things first, who are we? Affinisep, it's a French company created a decade ago. It's an application-oriented company specialized in sample preparation tools, and we have our own laboratory in France, so we are a French manufacturer. And thanks to our distributor network, we are able to sell such as 80% of our products worldwide. And we also have a US entity created in 2019. Which is our expertise. We are developed and manufacture all of our polymeric resin from the beginning to the end in our laboratory. And thanks to this experience, we are able to adapt our products with physical and chemical preparators according to our customer needs. So thanks to that, we are able to innovate for and with our customer. Affinisep has 3 different application fields. The first one is in food safety, and our products are based on molecularly imprinted polymers. It's really ready-to-use kits for the selective extraction of different contaminants, such as pesticides, mycotoxins, antibiotics. We also have product for environmental analysis, and it will be the main topic today. I will explain you much more later, but our products are based on passive sampler for to capture different contaminants such as pesticides, drug residues, endocrine disruptor, PFAS, etc. And Affinisep also have products for bioanalysis and proteomics for key step before LCMS for peptide desaltic, fractionation, protein purification. But let's focus on our main topic today, environmental analysis. So first, I'm going to explain you what is a POCI. POCI is for Polar Organic Chemical Integrative Sampler. It's a type of passive sampling. It's based on two diffusion membrane, which inside some powder in solid phase, which will capture all the contaminant present in water. This diffusion membrane with the solid phase is capped in an outlet, in a metal outlet, and that is a POCI. So these passive samplers are put in some holder, and to protect them, you put them in some canister to protect them from big contaminants such as wood, which could damage your passive sampler. And then you will put your canister in your environment for such a long time, between 1 and 4 weeks, usually. And in the environment, your passive sampler will accumulate the contaminant. So why you think a passive sampler? There are a lot of different methods for water sampling, and passive sampler has some advantage instead of some usual water sampling such as groundwater. So for example, passive sampling doesn't need any power, maintenance, or supervision. The main advantage is that they can detect spot release. Indeed, if there is some release of some pesticide due to agriculture, if you do some grab sampling before or after this release, you may not see that release. And instead of passive sampling, you will detect it. So it's able to have some average concentration and limit variation. Before the deployment, the storage of passive sampling, it's really easy. It doesn't need any specific condition. It's able to have some a really low limit of quantification. It retains chemical information. There is no metabolism in the passive sampler. And it's really easy to combine passive sampling with some biological analysis after that. And we have different formats according to which situation, even if for groundwater. So now I will explain you how does that work. So when you have your passive sampler, as I explained you before, you put them in some canister to deploy it in the environment for such a long time. After that, you will recover it to do the extraction. So recover the powder, if it's supposed to do the extraction in the laboratory. And thanks to that, you will have the concentration in your contaminant according to the mass of sorbent used for the passive sampler. But if you are interested in the average concentration of contaminant in water, which we call time-weighted average, TWA, you will need to use this formula. So you will need a sampling rate value, which you will find in literature, or if you prefer to do it with calibration in the same condition in your laboratory. And moreover, if you want to have some average concentration of contaminant in water, you have to work in the linear part of the accumulation of contaminant in your passive sampler. That means you don't have to let them too much time in the environment if you want to be in the linear part and not in the equilibrium part. You could also use, as Davide used in his publication, PRC compound. PRC is for performance reference compound, and it's some molecule which you will dope in your passive sampler. So our POCIs are disponible with or without, according to your need. We use D5-DIA as the PRC. It's an atrazine, it's a deuterium atrazine. So as it's deuterium, it is not present in the environment, and as it's an atrazine, it looks like some molecule you want to catch, so like pesticides, and it will mimic how your contaminant will react with the passive sampler in the environment. So as you let it some time, the PRC compound will decrease, and it's the opposite of the contaminant present in water, which will accumulate. So PRC are able to give some qualitative information on the flow exchange between the environment and the passive sampling. Now you know how those passive sampling work, but which passive sampler choose according to your application? Well, Affinisep have a lot of different passive sampling according to which contaminant you want to choose. So if you are interested in polar contaminant, we have two different devices. The first one is called POCIS, and the other one is passive sampling based on disk. In the next slide, I will explain you the difference between them, but it's a good device if you want to catch pesticides, drug residues, glyphosate, or PFAS. If you are interested in non-polar contaminant or hydrophobic micropollutant, the best passive sampler is silicon rubber. It's for PCB, PAH, or PBD, for example. And if you are more interested in microalgae toxin, the best passive sampler will be SPAT. Affinisep also can give you DGT if you are interested in metals detection. And we have different formats according to the environment, as for groundwater or piezometer. And also we have different size of canister if you are interested in putting much more or less passive sampler in one site. So which is the difference between POCIS and passive sampler based on disk? Well, as it's in the noun, POCIS are based on powder and passive sampler are based on disk SP. For passive sampler based on disk, you can use them without the diffusion membrane, and that includes the fact that you can capture a broader range of contaminant. And thus, there will be a faster accumulation and you will let it less time in the environment. But if you keep this diffusion membrane, POCIS have a biggest exchange surface as there is a larger window of 55 millimeter instead of 40 millimeters for disk. To conclude, if you are interested in average concentration of contaminant in water, as I said in the beginning, you need to determine some sampling rate value. And for that, one solution is to do calibration in laboratory. So for this, you will take some tank with water spiked with contaminants. You will add some water to mimic the flow rate of your environment, and you will put your passive sampling device. You will recover it in few times. Here you can see the example for 7 days. You recover 1 POCIS per day to see the accumulation of contaminant, and like this you will find the sampling rate value. So thank you for your attention, and if you have any question, don't hesitate to put it in the chat. We will answer everything at the end. So now it's time for our speaker.
Okay, so many thank you for this kind invitation. It's really a pleasure for me to be here today. Thanks for the introduction. So the idea is to present you the work we published recently about the passive sampling in Camargue in south of France. The idea was to apply this technology to a bioremediation and a phytoremediation solution, but more in general to understand better the behavior of this micropollutant in the environment. So just the context, the study area is the brackish water in the Camargue, south of France. So in a quite challenging environment because it's influenced by fresh water and seawater. There is a dynamic transition between this environment with salinity variation and several agricultural activity, in particular rice cultivation around the sampling area. So the system was applied to an existing phytoremediation system based on Phragmites australis. But for us, as environmental chemists, the main interest was to understand the behavior and the dynamic of micropollutant in general. So we use the same scenario to test the phytoremediation approach, but also to understand the seasonal variation of micropollutants. So the focus on the area, we are here in the natural park of Camargue. The point is, you see sampling area is in a phytoremediation installation based on 3BS, so sedimentation basin, in which water is basically calmed down to increase the sedimentation of minerals and salts, and then follow the phytoremediation and come back in the natural park. So there is an influence of water from the Mediterranean Sea with the salinity, and fresh water from the river with, of course, several pollutants of the industrial zone, and moreover, the general agricultural activities around this sector. And we know that we are facing to a complex pollutant dynamic influenced both by agriculture, seasonal application of pesticide, and the natural hydrological cycle, also due to the sea. So we decide to stay larger as possible. We select 483 organic pollutants divided mainly in herbicides, insecticides, fungicides, and metabolites and degradation product based on some list based on high pressure liquid chromatography tandem mass spectroscopy we have in our lab. And we select 7 metals, only 7 because this area was already studied for heavy metals, and we know that these 7 metals are the most interesting for this study area. So we decided to focus only on a limited number of metals. Our main aim was to study the dynamic of organic pollutants. So in terms of, because we are facing to a complex pollutant dynamic, the idea was to use plastic sampling, but this was already presented, because in this situation, personally, I really like plastic sampling as a technology. We have several projects with this technology. We can overcome the limitation of the traditional sampling. Indeed, the classical spot sampling is not enough to represent a high variability over time, because we stay 11 months in this area, and in particular when we are facing to a long-term monitoring. We are not interested in spot measure. We are not interested in high or very low value. For example, after an accident or an application of some chemicals, we are really interested in a trend. So this kind of technology allow us to obtain an average concentration over time. We decided to use HLB POCIS approach for the sampling, and DGT for the sampling of metals. As I explained, 2 main objectives. First, conduct a comprehensive seasonal monitoring of these pollutants, focusing on a quite large spectrum of organic compounds, contaminants, and heavy metals, and also evaluate the efficiency of the phytoremediation system based in this plant. You have the picture on the right, to the ability to remove micropollutants and heavy metals in the system we have in place. So this is the methodology, sample strategy, and the slide description. 9 campaigns. We first, because of the variation on salinity, we spend a few months before these 11 months to test the best exposure time. And this was done by using passive sampling at several times, so 1 week, 2 weeks, 3 weeks, 4 weeks, 6 weeks. And compare these results with a spot analysis, basically daily spot analysis. And we select 3 weeks what's the best timeline for the exposure. So we perform 9 campaigns of 3 weeks per campaign from January to November 2024. In different points of the phytoremediation system at the entry point, which is exactly the water of the surrounding area. So for us, the entry point is also the 3 entry points you measure are basically 3 points of the environmental water, and then we have 3 points in the 3 sedimentation basin, and 2 points at the end of the phytoremediation system. In a from a pure technical point of view, we were quite happy with, so we work in duplicata, 3 points, each point in duplicata. We test recoveries from the sampling units, not only from the environment, but also in laboratory. So basically, we test the recovery of POCIS exposed in water with the addition of some pollutants, but also the capability to extract these pollutants in the lab. In terms of results, we start with 483 compounds, and we detect 100 compounds of this list. 41% were herbicides, 30% fungicides, and the rest different classes of compounds. We also obtain a statistically significant seasonal variability. So I show here only the compounds for which we observe some statistically significant trends. So these follow some seasonal variability, and as I will present soon, this is related basically to the application, so the current agricultural application. For sure, we also detect some quite old chemicals used in agriculture, like metabolites from atrazine. These kind of compounds, they are still in the environment, but they don't follow a seasonal trend line because they are more or less present at the same level. The trend is not only in terms of concentration, like in the left, but also in the right in terms of percentage of presence over time, with a quite high presence of chlorantraniliprole and bentazone, two main products used in this area. About heavy metals, so we also saw some seasonal variation. Barium and copper, we have some peaks in autumn. We don't have today an hypothesis for this, if it's related some agricultural activity, for example, in particular in post-harvest condition, when soils are treated are basically impacted by the agricultural activity, and a peak of silver and tin during the summer season. This is also not really explained if it's we also have some hypotheses about some activities linked to the tourism around this area. However, we don't see mercury and cadmium that are both below the limit of quantification. So you have here the trend. The trend line is less marked, like compared to the organic pollutant. So this confirms that the focus on organic pollutant was a good one to highlight the presence of this of pollutants in the environment, and also study the behavior of this phytoremediation installation. These were the results from the environmental monitoring, and now about the phytoremediation. So what we notice is that concerning organic pollutants, we have a high removal efficiency, up to 95% of the whole organic content in the phytoremediation plant, in particular during April and May, and a measured decrease in July. This was explained by the specialists in phytoremediation by the biological cycle of life of plants. They grow up in April, May. It is the best season, the April, May, but also during the autumn, September to November. On the opposite, during the summer, during the hot condition, the vegetal activity decreased a lot, and we observed this. We have a major decrease in the air removal efficiency of organic pollutants. This information is critical for this kind of scenario, because in this region they are pushing the use of phytoremediation to basically clean the environment, but during the climate change, we have a major increase of temperature in this region. So we will impact in the next years. We know that this kind of installation, they will be probably more and more impacted by the temperature. so reducing the efficiency of this treatment. This also show the importance to combine this kind of treatment with some seasonal monitoring to understand the biological behavior of this installation. For heavy metals, the concentration was overall quite low, so it's not a major pollutant in this region, and actually the impact of phytoremediation was variable with no clear trend, but we detect an increase of heavy metals during the summer. This is also explained by the biological conditions. So plants are stressed by the temperature, and they can also release some metals that they absorb during the year. So we see that for heavy metals, the best season is more autumn, and summer still remain quite critical. So overall, today, phytoremediation based on Phragmites australis is an effective natural-based solution. In particular against organic contaminants. We show also that we can monitor this, but the relation, more studies are necessary to study the relation between temperature, climate change, and this kind of approach. So in conclusion, we show in this paper that with a passive sampling installation, we can follow a quite large number of organic pollutants over time. So we can really capture seasonal variability in brackish water, which are basically quite challenging due to the presence of, due to the salinity. In this scenario, in this situation, we observe that agriculture has a major impact in this seasonal fluctuation we observe with less hydrological influence due to the sea. So the fact that the sea is present, the pollution from the sea, also the pollution from the fresh water, even this fresh water passed through industrial areas, is less impacting agricultural activity are the main challenge for this region. We show that this kind of phytoremediation installation show a good efficiency for organic pollutants removal, but we show also, on the first time, clear impact of the seasonal variability of this treatment with a decrease during the summer, probably due to the temperature, and this must be studied because if the plan is to continue to use this kind of installation, it's important to evaluate the type of plant people use and the impact of environmental change on the use of this kind of plant. In the future, the idea is to use this not only for this kind of vast region, but also to follow more limited environment with high human pressure. So combine passive sampling with some real monitoring elements, quite simple to apply, like pH, conductivity, temperature, to try to check if there are some correlation between the presence of pollutants and these physicochemical variabilities. The idea for sure is to extend the periods of work on several years to have a statistical data set and try to add additional pollutants by adding, for example, more pollutants on the same list, or even better, different passive samplers in the same canister or in the same sampling point to have a larger number of micropollutants for the analysis. And then, for sure, as I explained, to really combine this know-how with this practical application like phytoremediation to provide support in terms of regulatory decision, but also project management and technical decision when this kind of phytoremediation solution are applied. So this work was coordinated by the University of Lausanne in collaboration with the Haute École de Fribourg in Switzerland, my colleague Professor Lucarini, our company in Monaco, Daxtachem, which is involved in chemical analysis and environmental monitoring, and some partners in France, the Centre d'analyse Méditerranée des Pyrénées et the Society BCN. Many thanks for this invitation. Many thanks for your attention. So now I'm available for any questions.
Okay, so thanks a lot for your contribution to this webinar, Davide. Thanks a lot for attending this webinar. So do not hesitate to write us if you have any question, or to write to Professor Stedler if you have any question. Thanks a lot. That was very, very interesting. Thanks for your time.
Many thanks for the invitation.